In this example, we have another translation question, another translation example, where we would like to translate this English language statement into a logical statement involving propositional functions, or this I wrote predicate function in the notes, or logical connectives, quantifiers, stuff like that. So let's start by just going through the message here and kind of saying what's what. So this says at least one mail message. So this part here that's at least one tells us that this is an existential quantification, right? So there exists at least one and mail message. So the mail message part, we're told right here, this is going to be part of our domain of discourse right here. So this is our domain for the variable that we'll call x. So there's our x domain. It says right here it's the non-empty set of messages, but we can just say that it's the set of messages. This message then can be saved, right? So there's a propositional function. P of x is x can be saved. And then we have a logical connective here. So this is a conditional. If the if connection, when it's written like this, goes actually in this direction. What's coming after the statement is the if part, and what came before it is the then, right? It's the conclusion. So this is our logical connective that goes in the reverse order. And the next part we have to break this down even further now. So the next one says there is a disk. So this right here is another variable actually. So we can call this, say, our y variable, and the domain is now a disk on the computer, right? So the domain here is going to be the disk, and I guess we'll call it a computer. Maybe it's a floppy disk or something. I'm really aging myself there, aren't I? So there's the disk, and there is another existential, right? Another existential quantifier. And then we can move on, and here's our last propositional function. This one's going to be q of x, and x is going to have more than 10 kilobytes of free space. Okay, so let's go through and write all these down again. The quantifiers themselves are just going to be part of our logical statement that we end with, but we need to write down our domains, write down our propositional functions. So here's what we have. Okay, so x is, let's write this way. Let's make sure it looks like a capital X. We'll say X. This is the domain for the lowercase x. So this is the set, right? The set of messages, which we can say it's non-empty. That's not really necessary for what we're about to do next, but it is non-empty. So there's at least one message in this set. So the set of messages. Capital Y, this is going to be the set of disks in our computer, in our server, whatever it is, right? So let's call it a server just for fun of it. But this is the set of disks, and these we're calling y, right? And then we have our two propositional functions. They behave. I made a typo here. They work on the different variables, though, right? So q was really a function of the variable y. It was q of y. So you could still write it as x. Maybe we should, just so that we can see how this will work, right? Put the x back in there. So p of x will define, when I say, really I should probably leave it as a y right there, and we'll define it with x down here. But p of x is then the statement that says x can be saved. Right? So this is the propositional function that tells us that the message, in this case, can be saved. Q of x, I'll use the x here, says that x has more than 10 kilobytes of free space. So x has more than 10 kilobytes of free space. All right, and then now we just have to remember that actually instead of x, we're working on y, right? We're working on this domain. All right, now let's take a minute to think about how we're going to unpack this message and write it in terms of these quantifiers and propositional predicate functions and what have we. Remember, the arrow is going from right to left, right? So we should go in order of the statement, but to make it look the way that we're used to, we should probably start with the thing that's going to be doing the working on what we want to be the left-hand side of the arrow that's pointing the other way, right? So let's start over here. So this one says, if there exists a y, sorry, I wrote the x again, but if there exists a y such that q of y, then we go back over here, there exists an x such that p of x, right? So this is the statement. This is how you write this in terms of quantifiers. So that's actually the best that we can do because the quantifiers happen on either side of the conditional statement here. So you might think that you can pull out the quantifiers and write this as a nice simple statement of just the two quantifiers and then the nice logical conditional statement there. But it actually won't work in this case because the quantifiers themselves are in different positions with respect to the conditional. So this is the best that we can do. We'll leave it there. And see you in the next video.